Our first talk today is from Jan Mussler from Zalando. He will talk about their monitoring or how they monitor the infrastructure, the cloud services, and the website. So, give a warm welcome.
Yes, thank you, thank you. Now I'm much more pleased with the outcome of people listening to my talk than 5 minutes ago. Yeah, my name is Jan Mussler. I work in the Berlin office from Zalando. I'm a software engineer by trade. I studied in Aachen many years ago, and I want today to show you how we basically do the monitoring. There's very little Icinga in here, so if you are big fans of this, I hope I can show you something else today. So let's touch briefly on Zalando. I'm pretty confident that most people here know it by now. That was different when we visited conferences in the past, but we consider ourselves to be Europe's leading online fashion platform. We are present in 15 countries. We have right at about now kind of 19 million active customers. We have roughly 160 million unique visitors a month. We have something around about 200,000 articles on the page, so in stock there is much more. We currently advise around 3 billion euro revenue yearly, and probably the most interesting number here is that we actually have 1,600 people in tech. So this includes a lot of software engineers, a lot of engineering power to basically build our own software from the front end everyone knows, but also down to the logistics software that is responsible for steering processes in the warehouse. And that's actually why the past 6 years for me have been quite a good ride. I mean, there is scaling topics, there is a lot of stuff to do. You see this here, many years ago, there was PHP, MySQL hidden in Magento. Then we switched away and became very big fans of the Java and the Postgres world. We had a very strict environment here, so everything was in Java and in Postgres. There was Apache Solr in game also, but we weren't so open to other technologies that you would expect from a startup, basically. But come the past years, this has changed. If you want to hire engineers, you need more freedom. You need to tell everyone you can do it in Scala. You need to tell everyone you can use Go if you want to. So right now, I'm losing my headset here. This has changed. So there came, beginning of last year, I think, this term radical agility, and it's mostly about autonomy. So we gave all the teams a lot of decision power. First of all, there came AWS, so we can go into the cloud now. We can use all the technologies the team thinks fit, except some of them. But this obviously is a very interesting change. Suddenly you have this heterogeneous environment, everyone is doing what he wants, everyone picks the database he wants, and you still want to monitor across this vast array of technologies. So how do we deploy? In one sentence, so you maybe understand, there is one AWS account per team. This means basically one closed-off virtual network for everyone. We deploy with Docker, so this is the baseline we agreed upon. So if you want to deploy something, you put it in a Docker image and you can run this somewhere on an EC2 instance. We have SSH access for all the team members to all the hosts, so there is no limitation there. The other thing we employ is there's REST and OAuth between all the services. It's all going via the public internet. And in the end, the important part for us is also traceability of changes, so audit streams and so on. But if we take a look at this, basically means there is, if we pick 2 teams out of the hundreds of teams, they have their own domain somewhere, they have all the services and internet-facing load balancers, they talk HTTPS, and then they use OAuth 2, so sending a token for authentication or authorization. And that's basically how it works. So there is no VPN, and there is no special connectivity. It's like the internet is supposed to work. So along with this came obviously also a lot of responsibility and ownership into the teams. So while some of you may still be, and we had also very long time ago been basically in this world. I recently quickly added this slide yesterday. We had lots of teams. We had a system engineering team. They were writing tickets for the team responsible for this monitoring solution, and they were basically monitoring everything. But I mean, everyone can imagine this explodes. If everyone can use whatever he wants, has its own freedom, this doesn't work. So what we actually kept in mind, and this is the big important thing here that has changed, is that teams are solely responsible for monitoring their stuff. I mean, you can say DevOps and also on, there's all these buzzwords around, but basically the team is responsible for their stuff. They are monitoring their application, they are monitoring their KPIs, they are monitoring their system metrics. So when we set out to build a tool, I think, what was it, 3.5 years ago, this was the strong focus, basically enabling teams to do the monitoring on their own, do their own decisions on what they want to look at. And we are not talking like CPU memory. Most of the monitoring is also in higher level metrics. So do we have enough orders in France in this certain payment method? Do we have enough visitors from the certain channel? So really higher level APIs. Yeah, so this is just one example how it basically can look like in this modern cloud world. So you have different hosts, everyone running their applications. You need to know what is running where to do the monitoring efficiently. So, and here is where ZMON comes into play. It resulted from a Hack Week project back then. So a few engineers sat together and started building something. We called it ZMON 2 because there was already basically a UI for what we had earlier, but now we renamed it to ZMON. You can find it on the web. It's all open source. And that is really what we are running. That is the key part. There is no hidden magic. So we run a 100% open source project on our internal infrastructure. We commit and show everything to the outside that we are using, including all the features we need for this multi-region monitoring, because we have data centers, we have AWS, and we have all this federated into one solution. So let's take a look at how it looks like. It may be way more interesting. So you see in the next few slides basically a feature set of ZMON. So what can it do and how do people achieve this? And I just want to highlight here a few key points. So basically, to scare the first guys away, there's Python in play, and you have something like checks for data gathering. You have alerts for alerting on metrics, and all this is in Python. But stay with me, it's really tiny snippets of code, so this works well. The other important part, if you drive such a big platform, is integration. So everything is basically controllable and configurable via REST APIs. So if you have a new host or a new piece of software, a new application, you make one REST call, you announce basically your service to ZMON, and can from there on out start monitoring it. And for some systems like AWS and Kubernetes, we obviously have auto-discovery. So whenever someone spawns something on AWS, it will immediately appear in the system and be well covered by all the checks that existed before. I mean, this is crucial, basically. And earlier, when you think about the data center, we had the configuration management database where all the hosts were in with their physical model and so on, you will see later. So all this happened automatically. So whether it was an HP server or a Dell server, it's all basically covered. Yeah, for most of the other stuff, it's basically UI driven from the user. So he doesn't have to go anywhere. He can do all the stuff by himself. And in terms of scaling, we basically put together a fairly proven set of technologies here. There is Cassandra in there combined with KairosDB, which is great for basically time series data. On top of this, everyone wants to have Grafana2, so this is all in. A little bit of Redis to power the UI also, so we are not afraid of growing the system, basically. What did I not cover? That's all done. So how does it look like? First thing we basically built is dashboards. So you want to have your TV screens on the office, you want to have it on your desktop, you want to quickly see when stuff goes wrong. So what do we have? We have basically alerts that are triggered, and people can assign basically colors between red and yellow. This is not the old state like warning or critical, because no one looks at warning, if we are honest. So everything basically is up to the team to say it's either red, yellow, or orange. We have an area on top basically where people can add custom widgets from single stat values to text values to other basically Kairos powered charts. And this is what people basically render on one TV screen. So they have the critical alerts up, they have some of the key KPIs written on top, and normally you will see a second TV screen rendering a Grafana2 dashboard. What we basically put here in also from learning is stuff like you immediately want to see how you came to this alert. So basically, if you are tracking metrics, we also render the charts immediately, because it's a difference whether your alert came up in the last 2 minutes or in the last 14 days, basically. We have a little bit of tiny data in here, like for example this exclamation mark, and this is basically showing a technical error during data acquisition. So basically showing you we are not certain what the system is showing, we couldn't gather the data, so you better take a look at it so you are not basically blind. We are not hiding this error from you. So how does it quickly look like? We go briefly into more details later, but you see here a combination of an alert expression and a check expression. So basically when you go to the check command first, I hope this is somewhat visible, we tell ZMON basically make an HTTP request to some system every minute and return us the status code. And then you say, okay, if my status code is not in 200, 400, and 404, please trigger this alert. So this is really like high level, and I think everyone can understand it. Maybe take with you that there's something like an entity filter here, but we come into this later. So this is how it looks like. And this basically means we find all the stuff that is matching our filter. We do the HTTP request against it. So we have 5 different applications here. They return different status codes down here. One of them failed with a timeout because the port is not open. And so this is basically how we render alert state for this check. So the team now basically knows, okay, one of my 5 entities is wrong. I better take a look at why this is not open. So what else did we add? We went into this microservice world, so people started deploying stuff like crazy, and you want to give them a better overview of what is going on in their account. And since we knew we are doing HTTP almost everywhere, we know kind of how we deploy. We built in something like this application overview. This is basically showing all the services one particular team has in his account. So basically we show the different microservices, and we also quickly show the data you are kind of care for. So how many instances is it running, how many requests, how many 400, 500s, and latency, and so on. So by looking at this, you can basically get a quick impression at your services. If you care for more data, you pick one of the services, you dive into detail here, and you basically get, I just copied this from the demo, so the request count is pretty low. But what you can imagine here is if you are looking into this microservice world and you have REST APIs everywhere, what you want to see is basically not an average over all your endpoints because they vary in behavior, but you are basically caring for the key APIs people are calling and how do they behave. So we built some more UI around this. The data gathering is the old way you saw before. Then everyone, I think, coming from other tools, he liked to have this overview. So let's give me all the hosts and show me all the stuff that is good or not so good. So we can also do this. You can basically select a subset of the stuff you're monitoring, and we will render for you basically one green box for an alert that is fine. And then depending on the configured colors, there is yellow and red boxes for stuff that is not okay. So when we go back here earlier, I think the worker here, this was basically the one error you saw before. It's this one red box that there is no status code returned here. So the user interface you saw earlier basically is requiring really full authentication because we built this in the Zalando world. We still needed to expose this to everyone. We also wanted to expose this to everyone without VPN. So this is basically running out there on the internet. You don't need anything special to access it except your credentials, obviously. We support in the open source version basically logging in via GitHub because this is the most convenient way to implement so people can quickly get started. Then we have filters on GitHub organizations and usernames, so this works out of the box. So everyone who basically goes now to the demo.zmon.io, he can log in with his GitHub account and start playing around. Another use case you often face is you want to have TV dashboards in your office, but you don't want your credentials in there, so you need to make this possible. So we built these basically one-time login tokens, so everyone can basically activate a TV screen on his behalf. Grafana2 is in our software, so basically we re-implemented the Grafana backend API so that there is really one UI. You log in once and you get full access to both ZMON and Grafana within there. We store the dashboards for you, tagging, starring, all the stuff you basically know from before, but just you get all the data we gather out of the box. This also means that we basically have an authentication proxy in there in front of KairosDB, so we also connect other data sources in the Zalando platform, so enabling teams to have their own KairosDB somewhere for their metrics, and then they can render a dashboard in ZMON for their data and the monitoring data. We see this in Grafana basically. When you look back in the trend, what Grafana did, they built the same thing. So they built also this backend in Go, I think 2 years ago, and we did this slightly before because everyone basically needs authentication. How does it look like? I mean, Grafana, everyone knows it. So everything you track, every numeric value that ZMON acquires goes into KairosDB, and you can chart it. It's annotated with basically where is it coming from, this value, when was it basically measured. And this is basically what gives you, we'll see it later, pretty nice metrics. So this also allows you, for example, to track behavior across different software versions and so on. So did you fix something? Did you improve something? Did latency become slower with a new version and so on? This is basically all happening automatically. Since we are talking about monitoring, there's one question you want alerting when you're not looking at your screen. So email is there. We can basically trigger Slack. We can trigger HipChat. We are working on and basically betaing right now Twilio phone calls. This is all there. We also have support for PagerDuty and OpsGenie. So I mean, this is easy. They all have a REST API. Just need to trigger them. There is no magic there. But I kind of prefer this Twilio thing. It has a very low hurdle to get into it, and it's not so expensive. We also recently added push notifications for basically the web browser. This is a pretty neat thing. So you have then notifications on your desktop, but this also works flawlessly on Android phones. So the website renders on the mobile phone, and you can just subscribe to the same amount of alerts there, and you get the trigger on the phone, even if you're not opening your Chrome. And what we have here basically is you tell the system, I care for this team's alerts with a priority 1, which would be all the red alerts. Please show me a notification if something like this pops up. And this is how people steer criticality and alerting in their software. So let's look a little bit at how ZMON achieves this. So there is entities in place, and this is basically what we use to describe our infrastructure. So if we take one step further, basically there is one entity for every physical host, for every database we have there, but also for kind of logical stuff, for an application, which is not really describing a host in particular, but maybe only application properties. There is instances for AWS EC2 instances. There are ELB entities for load balancers and so on. And this is basically whenever you have software you want to integrate, you basically push entities, and you basically create a JSON document, describe the properties. I hope everyone sees this here. There is like an ID that is unique, and then it's a host, an IP address, and whatever you want. And when you later say, okay, now I want to see if all my hosts are up via ICMP, you do a filter for type host, and then you write your check doing an ICMP stuff. And this is basically how it all works. So what is crucial here is that this entity, they give you a lot of flexibility in describing your infrastructure. So when you look at like what teams are doing, they have entities for the application, and then it's tagged basically with their team name, with their application name, with their application version. So this is how they then go on and basically filter, and how data in Grafana is annotated. It's basically reusing fields from these entities to see where data is coming from. And this is also how we basically connect right now. So when I said earlier AWS auto discovery, this basically means for a new EC2 instance, we create one new instance entity, and in the data center we do the same thing. If there is a new physical machine somewhere, we also do this. There is a command line client for doing this, so it can push YAML files, makes working with it very easy. But obviously, if you really want to automate this, there is also a Python library that you can pull from your system and directly push into the other system. And this is kind of how we integrate into services. So next thing is the check, basically. The check is the data acquisition. So you saw earlier we are grabbing the status code, but this is the tiniest example we have. So this gives you one numeric value. But in reality, it's much more complex. So most checks, they return like dictionary objects. So if you look at CPU load, you normally track the 1-minute average, the 5-minute average, and the 15-minute average. This doesn't mean you have 3 checks in place. It just means you have one simple check returning these 3 values in a nested data structure. And where we did all the integration in the past, because we had this huge environment already, so we have like support for querying Postgres databases, support for Cassandra, Elasticsearch, MySQL, Amazon CloudWatch, so Exasol, Oracle, SNMP, and Nagios NRPE execution is also in, so this is kind of important if you look at what most people have in a data center. Maybe that's what they want to do. And this Python code is then also often used to do some filtering, data formatting, or kind of sometimes switching the dimensions here. And in the end, we see this, that no one returns a single value from the checks right now. Mostly it's much more complex, because most objects monitored have a vast set of properties. So yeah, saw this earlier, quick recap here. So really you write a little bit of Python code for your data acquisition. So you go somewhere, you go to a certain path, you return JSON, and then you do some filtering. What is kind of might scare people away, it's that you see a lot of code right now, but what is basically true is you do this once. So one team comes up with Elasticsearch monitoring, they write a certain set of checks for Elasticsearch, and every other team can reuse this check. Because the check in itself is not really tightly coupled to their particular software, it's basically coupled to Elasticsearch. So whenever someone else comes along and say, oh, I have Elasticsearch too, he creates an alert and reuses basically this check. So benefiting hugely from knowledge people expert to the technology already put into it. This, for example, happened with Cassandra, this happens for most of the AWS infrastructure and so on. Yeah, so just I threw this in yesterday because I got the impression that most people are more interested in like, or some people at least would be, and can we do this monitoring of infrastructure where Nagios and SNMP and so on and all these OID walks are still crucial. We can do this. So you basically see people monitoring here a Dell machine with a different command from the HP machine to monitor the RAID and so on. This can all be done. Yeah, the SNMP, I mean, everyone looks how this looks like. This is a little bit more ugly. Okay, yeah, also REST API to manage all this stuff, but right now it's all UI driven. So that is, that's the old flow, was basically people have the check somewhere in Git and then auto import it, but that doesn't work. People want to use UIs. Yeah, there is a trial run, so this is basically the debug mode. You go in there, you type your commands, you press run, it will run on the whole infrastructure. You see, this is the stuff I want, or you fiddle with it and you press run again and so on. So this is basically helping the everyday developer in the workflow. Yeah, let's go to alerts and questions we can do later. I hope you somehow got the idea. Write something, get data in, and then start alerting on it. Yeah, alerts are attached to checks. They are owned by teams, basically. There's stuff like inheritance, so you can reuse alerts also. But in the end, it runs a Python expression, takes the metrics gathered, and say, okay, now I trigger the alert or not. That's basically very easy. And again, you have Python, so you can do a lot of stuff. You can also look at the history data because we have the historic data. You can look at, does the value deviate from last week's behavior, from the average behavior in the past few weeks, all the stuff you want. But you need a little bit of brain power to do it yourself. But there is code basically helping you to achieve this. Yeah, no warning state, no unknown state or anything like this. There's only like technical exception or alert up or down. We have the priorities, they are free to use. You saw this earlier reflected in the colors. So if we go somewhere here, basically, let's look at Cassandra. We do a JMX query to a bean in Cassandra, return something, and then we want to see, is the down endpoint count come via JMX bigger than 1? So is 1 node down in Cassandra? Let's please trigger this alert. So this is no big magic. There is stuff like downtime, so everyone knows you do deploy software and during deployment everything goes red. So basically you can announce to ZMON, I want to deploy this application, please don't trigger anything on it. So this is basically how we manage this scenario. So there is a REST API saying, okay, host 01 will go down, please don't do anything. Yeah. I said a little bit about this. It's crucial to understand that there is a lot of reuse going on. So basically some teams are ahead in monitoring, are ahead in knowledge. They write something and other people basically look it up, they reuse it, and this is very helpful. The other thing is everyone can do this. So we have product managers doing KPI monitoring with it. We have system engineers looking at CPU load. There's KPIs monitored in Exasol, so huge basically data warehouse. There is stuff monitored in Postgres. And you see the vast array of stuff that is basically in there. And that's easy because Python, the data gathering Python is very compatible to almost anything you use. You're not really constrained there. Yeah, and the other thing is basically by reusing alerts from other teams, you're also able to monitor your downstream systems. So when you talk always to this API and it's crucial for you, you maybe want to have your own alert to see if this stuff is behaving as you expected. So yeah. So let's make one example maybe from the real world. So we set out last year to build our own OAuth infrastructure. So I said we needed something to create tokens and we need something to verify tokens. And we built this stuff. We built a multi-region solution using Cassandra in the backend and Java web tokens or JSON web tokens basically to do verification. It's very nice. You just need to you have basically JSON. You put a signature on it with elliptic curve. And then the verification is really cheap and fast. So just as a basically impression, Black Friday last week was somewhere in the 45,000 verifications for tokens per second. So it's really working. So Go is really fast, and you can achieve a 1.5 millisecond, basically, what is it, 98, 99 percentile. So this is great. You need some software to get a token, so do some credential verification. This is written in Java. And then there is Cassandra in the backend, basically only storing user credentials. So we have a huge Cassandra array to store a few user password combinations. But you have to keep in mind this is crucial. If this goes down, everything stops. So basically running really a core piece of software. And in front, for those not familiar with Amazon, it's an ELB, so a load balancer could be anything, HA proxy, F5, whatever you can come up with. So there's this agent, goes to the AWS UI, says describe instances, describe ELBs, and what we get is basically the stuff you saw in the picture before. By crawling the AWS API, we get something like an EC2 instance here, just to put a bit more picture into how an entity can look like. So we have the application ID, we have the host, we have an infrastructure account, so we know where it's running in the AWS world. We know the instance type, so maybe you can later see, okay, there is so and so much memory, there's so and so much cores, so depending on what you want to see, you have the region, and so on. But from this, you can basically grasp how people build the filtering on their checks and alerts. Second example, elastic load balancer, the same thing. We enrich it with a bit more metadata, so people can build alerts on, for example, number of active members, number of failing members, and so on. So this is sometimes hidden away in the entity and makes it also kind of useful for monitoring properties. If we then look at like physical machine monitoring in the Amazon world, some stuff is in CloudWatch with this Amazon metrics, but for the other stuff, we basically have reused the Prometheus agent. So Prometheus is this other monitoring buzzword right now, and they have pretty nice agents. So okay, let's use their agent for system metrics, run it on every EC2 instance, and with this we basically have access to disk storage, disk used by partitioned and attached volumes, to memory and CPU metrics that aren't all in the Amazon monitoring by default. So basically we run one Docker image on an EC2 instance, we run a logging agent shipping our logs to Scalar or other solutions, and there is the node agent on a different port. So we can basically with HTTP monitor all the stuff that is crucial to our infrastructure. Slightly more complex example here, but maybe you can see we want to look at different stuff, so failure detection and latency for read-write, and we iterate over it, and this is basically the rough idea here. So we track Cassandra up-down state and latencies, and what happens here is basically after running, you get back this JSON from ZMON, and it shows you all the fields you selected earlier. I hope this is kind of understood by now, and this data goes straight into KairosDB, into, what is it here, 10 different time series for one particular host, and then you can start basically building your dashboard with this. And this is, so for some people, ZMON sometimes is just this cron job, grabbing a number, putting it into Grafana so that they have a chart. It's not always about really active alerting, but very, very helpful. So how does it look like here from the UI perspective? Everyone, or not everyone, I hope everyone has seen Grafana because it's a great open source product to use. You see here the different curves, the different tags and annotations. Looking back at the ZMON UI, basically this is a dynamic dashboard, so for every check we can basically pre-create one dashboard because we understand how the metrics are stored, so you don't need for every check to build your dashboard. The default behavior, like showing the different values, is in there. We have stuff like deep links, so this is also easy to integrate. So this tiny cloud icon is a deep link into the Amazon UI, which is really helpful. So you have the instance ID and the entity, and then you can directly link and filter to Amazon, and then you get your instance there. And you can imagine you can also do this for other tooling because you have the data present in the UI. So here's one example, basically switching traffic in Amazon. So basically we have two different versions. So the curve here is, the upper one is the requests per over time, and the lower one is latency. So basically we deploy here, traffic goes down on one stack and goes up on the other, and then you have this latency skew on the new one. You're slow in the beginning, and the other one becomes slow by basically ELB metrics becoming less traffic means often a latency increase. But this is really how it looks like in production when you monitor stuff. And this would also enable you, like with your human eye, to see, okay, the new version is slower, the latency doubled and so on. But basically this shows you we have this metadata in there to understand this is a new software version from this point in time, and this is helpful too. Yeah, this we had, so there's stuff like also template variable replacement from the alerting, not really much magic. Don't think so much about the plus here for the percentiles. I think there may be a talk later talking you not to some percentiles, but that's a different use case. Yeah, this is already shown. Basically, Grafana tables does also work nicely with the software. So what have we learned so far? A lot of people do HTTP requests, which is fine. We read data for JMX, so from Cassandra. We read Prometheus data in this Prometheus format from Prometheus agents. We use CloudWatch to monitor the ELB. And we go to our logging provider's REST API to do the default log file analysis, so monitoring for warning, error, and so on. Yeah, now we will scare you a little bit away, because quickly covering the deployment. You can imagine this is not basically for free, but there is Docker to the rescue, and I will show you later. So this is just the tech stuff involved here. So this is basically why it's fun to work on this project. It's a project where you have everything you ever want to work with. So that's really cool from the engineering perspective. But one part down here is like Cassandra KairosDB. So this everyone can use for time series and disconnect from ZMON. But obviously some people are scared by Cassandra. That's kind of true, but it's also one of the easiest basically to get running and working. Redis is basically a very reliable piece of technology, so that's also easy to run. And then you have our own components around this, basically the controller driving the UI, the scheduler who takes part of running what and when, and the worker who is doing the heavy lifting, who receives a task, goes somewhere, grabs data, and persists it. For all the stuff you see here, we are basically providing Docker images. So as I said, we run this in our infrastructure too. So we configure the whole software using environment variables, and we provide basically the demo on demo.zmon.io, and the whole setup is also in GitHub. It's one shell script, and you can see it's basically 5-6 environment variables per component, but it's understandable. We know that there are some other deployments, also some new ones in the recent weeks, and they have managed with the documentation to basically get this running. And one guy, he's even running this federated setup, so he is doing multi-region stuff with it also. And here, I mean, this is the other big buzzword right now, Kubernetes everywhere. So we also have a repository describing how to deploy on Kubernetes with all the service definitions, the deployment definitions. And this is, I mean, the prime example for Kubernetes also. Running on your local host, you get going in like 5 minutes, depending on your download bandwidth. Because like there is Minikube, you run it locally, that's great. And that's also easy to run on anyone's basically playground. So this is like all the components you need. This is straight available. Okay, some of the special topics, I don't want to go so much into detail, but we came from a world with 2 data centers basically connected to each other, so shared network, but that's not always true. And for AWS, for us, it's not true at all. So we built these features in there that people might need. They might need basically to be able to split workloads into 2 different data centers, into 2 different VLANs and so on. So this can all be achieved. We put this into basically by dynamic filters. So it can depend on filters, entity properties where stuff gets executed. Yeah, that is interesting for some people, I hope. Yeah, this is how it looks like for us, or how anyone does this multi-region stuff. So we run something as the appliance, so a subset of the components you saw earlier, and they kind of in a federated manner send data back to our team's AWS account, where we provide the service of running Cassandra, the UI, and everything they need to do it. They just pick these few components, start it up in their account, and they are good to go. The Microservice World, I showed this already earlier. That is really like what we added recently. Just to briefly go into it, I think this is very helpful when you think about looking at your live performance. This is really like real time. It refreshes every 60 seconds, so you get really a good impression of what is going wrong in your service. And this is slightly the paradigm shift also. That this is the first time we built the UI to out of the box do stuff. So maybe you understood earlier people needed to do something. You needed to do a check and an alert in the Grafana dashboard. And now we have this slight more service shift change. So we are now providing like for HTTP APIs a better user experience. So people get used to New Relic or App Dynamics. They log in there, they throw this Java agent somewhere and they get this dashboard. And obviously we need to compete with this internally also. So we started building better UI for the default use cases. And obviously running microservices is the prime use case here. Yeah, the deep dive into a special service, so that's kind of okay. You see over time the basically exceptions and the non-okay status code, so you can easily track this. We render also the timing chart, so this helps a lot. And how do we do this? Basically, we have libraries for all the common frameworks, and they expose on a per application node these metrics. So if you want to expose this, you just include it, and you're good to go. There's almost no work required on the engineering side, besides adding this dependency in Maven, in Lining, or whatever people choose to use. And obviously this drives adoption also. Okay, I think I'm a little bit ahead of time, but maybe we can do Q&A. These are the URLs. Go to the demo, take a look around, go to the other pages. We have a Slack chat set up, so if you want to join and discuss stuff with us or need some help, we are happy to do this. We are really hoping to find at least a few more people willing to try it out. Yeah, thanks for listening today and enjoy the other 2 days of talks and monitoring.
Thank you, Jan. A lot of information, thank you. So, any questions?
No one?
Why KairosDB for time series?
That was a lucky coincidence. We had one other team that basically outperformed Graphite at the time, and they looked around and they saw KairosDB, and for us it was then a perfect fit because KairosDB has an HTTP API, which was perfect for us to basically integrate with the data structure we had in the worker, and we just started writing to it, and this basically worked from the get-go. And for me, the crucial part, it's basically it relies on Cassandra, and or at least we had experience with Cassandra. It works, it scales, and we know how to operate it in this multi-host environment, and that's just the good fit for us right now. A little bit maybe on the Cassandra, you have to ideally use one of the newer Cassandra versions because of how data is stored over time in Cassandra, so don't use the older versions, but we wrote this down. Yeah. This is independent of ZMON, really a very cool time series database that is very nice to use with Grafana and stuff. Very easy HTTP API, so for pushing data.
Any other question?
Yes.
Again for KairosDB, how long you are storing the metrics data for viewing and having dashboards for the alarms?
We promise users to do 3 months. That's not 100% achieved. Yeah.
Okay.
But when you really wonder, like Cassandra introduced recently this new data compaction, which makes it really, it doesn't care anymore about how many data there is. You could now do years. It's really nicely partitioned into, we have basically one Cassandra data file per day, and this is perfect. So basically, the old ones would always do this huge merging of files, but the new Cassandra has this basically time-based compaction, so it's really one file one day, and then after 3 months, one file is dropped, no I/O work, no rescanning of existing data all the time, so this helped a lot. And so for me, that's whether I do 3 months or 1 year is just a money question. Obviously, querying 1 year of data points without rollup will not work. But
when I understood it right, you have different teams,
yes,
which can build different checks and so on, and every team can do what they want. So how do you, is there any request tool for checks? For example, if one team has a check, it's called check disk C with the warning ratio of 80% and critical for 90% and so on, and the other team is doing it for 85 and 95 and so on, and call it a little different, so you have maybe 10 checks who are slightly the same but not even, so there is a lot of checks you don't really need. So is there any kind of a tool who says, okay, this check is already present, please choose this one because we don't want to have so many different checks?
First of all, I will say one sentence to the initial setup. So basically, for just not to mix the stuff. So first, there's like check does only the data acquisition. So give you a number of bytes free on your disk or partitions and so on. So this is what people would normally like look for in the existing amount of checks. So they would, sadly not all the time, but most of the time they would see, did someone have a check to give me this space from this particular class of hosts already? So the checks have a pretty good percentage of reuse, and whether teams then basically what alert thresholds they pick, that's really up to them, and this is where we don't care really so much, and there is no requests on this. So we provide, basically, we have a wiki internally and a hip chat for the user base, so pretty active internally on helping each other with all the use cases, and we link the most common ones to reuse, so be it from disk space to memory to API to load balancing. So there we have a kind of basically 10, 12 checks most people reuse, but then the threshold stuff is up to teams. Yeah.
So you pre-select through categories?
Yeah, basically you can just search and look at what people are doing. Yeah.
Okay, fine, thank you.
Okay.
Where do you do the check for threshold, if the thresholds are matched or not? In the time series database, do you do a query and then check it, or?
Yes. So basically, you saw the Python code, and the Python code, we basically have a lot of functions prepared for either be it Postgres, or there's the same basically prepared code for accessing the KairosDB. So you can then basically within a check or an alert basically use something called history wrapper, and then you write history, and then there is it automatically understands on which hosts it's running, so it will automatically query the curve for this host, but you can basically constrain it in any way you want, and then you basically get the time series data back in your alert or check context, and then you do it yourself. So when you look at, for example, the order week-on-week alert, there's really in the check, there's 3 different queries to going back 7, 14, and 21 days in time, getting a value, and then computing on this. But this is not, we provide kind of the framework of functions that can be executed, be it from, like you saw, HTTP to SQL and all the other systems, plus some core functionality to talk to the data we have in place.
Okay, thank you very much.
Great.